So inside of this linkage, we have 3 rigid bodies. By applying step 1, 2, 4, we find out both AB and BD, they share the same instant center, which is point D. So at this moment, remember, only at this moment, both rigid body AB and BD share the same instant center. Well, after 1 second, once the position changes, the bar rotates, and they're going to have new instant center, they probably won't share the same instant center anymore. All right, only at this position, at this moment, they share the instant center. And this is also the example in your book. It's called 2B. It's 2B4, 2B1, excuse me. Okay, we're going to continue this example. Going to 2B1. That's the one with 3 links. Okay. So in this example, if you read the problem statement, and we know a couple of things. We know omega OA. So we're given how fast, what's the angular speed of this bar OA, which is 3 radius per second. That's the angular speed. Omega is angular speed. That looks like W, but that's called omega. And we also know theta, which is this angle here. Theta equals 36.87 degrees. And we need to find out what is the instant center of AB. That's part A. In part B, we want to find out omega AB and omega DB. Okay, well, looks like we already finished part A from last Friday. We know where is the instant center for AB, which is at point D. We solved that, that's just point D. Sure. Alex, can you guys hear me? We have a couple of students join us on Zoom, so I'll make sure they can hear me.
Yeah, we can.
Okay, good, thank you. All right. Okay, so let's look at part B, how to find angular speed for AB and DB. That's stuff we want to solve. If we go back a little bit, if we look at step 5 and step 6, okay, at step 5, what's that equation? That equation tells us the angular speed of a rigid body, right? But in order to use that equation to solve angular speed, you need 2 things. You need what is VA of AB, can be any point on the rigid body, but you need to know the velocity or speed of that point. And that is a distance from that point to the instant center. So let's first look at, do we know any point on rigid body AB that we know the speed? Any point we know?
Well, we can solve for omega OA.
We know omega OA. Yes, we don't actually know directly the speed of any point, but we do know omega OA. That's a given. Can we use that to help us find the speed of any point? Right? If you check step 6, what is that equation? That's speed equals omega times distance. So if you know omega, you can find any point, you know distance from that point to the instant center. You should find out what is the speed of that point. So let's try it out. Since this point A, it's rigid body OA, and it's also at the same time, it's also part of rigid body AB. So that's a good point to start. So we can apply that equation. That's the second equation of instant center. So it defines the speed of that point, in this case is point A, equals omega OA times the distance from omega, distance from instant center to that point. In this case, it should be the distance from A to O. This R slash O. Let's look at this here. We know what is omega, that's given, just 3, times RA slash O, distance of that vector, of that position vector. It's just the length of OA. The length of OA, in this case we're given, the length of OA is L. AB is also L. Okay. It's given as L. Okay, so that is 3L. VA is 3L. Unit should be just meters per second. So now we know one point, the speed of one point A. Be careful here. When I apply this equation, you need to make sure that omega OA, it's the angular speed of the point of the rigid body have that point. That makes sense? You cannot use other omegas. And the distance here has to be, it must be the distance from the instant center of this rigid body to that point A. In this case here, point A is right here. And we're looking at this rigid body. We know the omega, which is OA, omega OA. And the distance from that point to the instant center, which is point O, the distance is L. Okay, now we know one point. We can go back to apply the equation from step 5. We can apply that equation to find omega AB. Omega AB, which is the next rigid body. So let's apply omega AB can be solved as VA divided by the distance from point A to which point? Now my question here, what's the distance we need to look at here? If we want to apply this equation, omega AB equals VA. On the bottom here, we should have a distance. That's the distance from which point to which point. I can tell you one point on that distance should be A. That distance should be from A to Where? From A to where? We only have 1, 2, 3, 4 points. Raise your hand if you think that should be the distance from A to O. Raise your hand if that should be the distance from A to B. Raise your hand if you think that should be distance from A to D. To D. Raise your hand. All right, the correct answer is distance from A to D. Why is that? Where is the instant center of the rigid body AB? Which point? Point D. So when you apply that equation, the distance must be from that point to its instant center, which is point D. Point B here is not an instant center for anything. So here it should be R A slash D. The distance between A and D. What is the distance between A and D? We're looking at this distance here. Oh, that needs you to apply trigonometries, right? If this distance is X, we know the angle, we know one side, we know, well, we can use tangent theta equals the opposite divided by adjacent. Well, that would tell you X equals tangent theta L. Okay, that's the distance from A to D. So let's grab that guy back to here. VA divided by tangent theta L. All right, so plug in what is VA? VA is 3L divided by tangent theta L. L cancel off. You have 3 over tangent theta. That is your omega. What's the unit for omega? Make sure you add unit. What is unit here? Radius per second. That's angular speed. Okay. All right. So now we solved this part. We find out what is omega for AB. We still need to find out what is omega for BD. Can we do the same thing? Find out one point that we know speed on rigid body DB. It would be easier to use point B, right? Now we know the angular speed of this rigid body. We can apply the second equation to find out what is the speed at this point. Because we know we can find out distance from that one to the instant center. Once we know the speed of that point, we can apply the equation from step 5 again to find out what is the angular speed of that rigid body. Okay, give it a try first. Let's apply the equation to find out what is speed at point B. Try it out yourself. Speed at point B. Question?
Since omega is positive, we assume it's counterclockwise, right?
Yeah, if no. So the equation here, let's see. Good question. If you apply this equation to find omega, that equation only tells you the value of omega, doesn't tell you anything about the rotation. So no information about rotation, either counterclockwise or clockwise. It only tells you the magnitude of that angular speed, which is this guy, 3 over tangent theta. And in this course, we all agree, and if the rotation is counterclockwise, omega would be positive. If the rotation is clockwise, omega would be negative. So to decide that is positive or negative, you need to go look at the diagram to see how that bar is rotating about its incident center. Okay. Raise your hand if you are to find the speed of point B. Okay. So find out speed of point B. You want to use this equation, right? Speed of point B equals omega times the distance. I leave something blank here. So I want you guys to tell me which omega we are looking at here. Should I use omega OA, AB, or BD? Which omega? Let me see. I forgot how many omegas we have. Okay, raise your hand if you think that should be omega OA. Omega OA. Raise your hand if you think that should be omega BD. Raise your hand if you think that should be omega AB. Okay, good. Should be omega AB. Okay, R here. So this R should be from point B to which point? Point to point A or point D? If it is point D, raise your hand. Okay, here should be point D. Point D is the instant center. This guy, it's the IC for this guy. Okay. Now we can plug in everything we know to find out what is VB. Omega AB we solved, which is 3 over tangent theta. And distance RBD, let's go back. What is the distance here? We can apply either way. Either you can use x squared plus L squared, square root. That would work. And plug in what is x. So here, tangent theta L squared plus L squared. That should give you the distance between B and D. Or you can use cosine theta. I think that would be easier, right? Also equals to cosine theta L. Yep, I will use cosine theta L. Here, cosine theta L. Here, I'm missing the, oh, no, I'm good. There's no L here. Okay, now we have the speed of VB. Now we can apply another equation to find out what is omega BD. Omega BD equals VB divided by the distance from B to D. Okay. What do you get from there? What's omega BD? wait a second, how come omega BD also equal to 3 over tangent theta? Is that right? RBD is the same. Divided that. All you have is this 3 over tangent theta. That's your RBD. You realize that RBD equals RAB. So there are two different rigid bodies, but at this moment, remember, only at this moment, they share the same instant center and they share the same angular speed. Okay. Any questions on this example? So far we're solved omega AB or omega BD, and we're done with this example. Okay. How do you guys feel about instant center? Okay. All right. So, but be careful here. What we have here, it's just a value of the angular speed. We didn't, since this problem only asks you to find out the values, it didn't ask you to find out direction, but you can go back to the figure, based on the figure how everything rotates, find out the rotation. Here is your instant center for AB and BD. Here is a point on AB. Let's look at how AB is rotating. Is AB rotating counterclockwise or clockwise? Can you tell? This is the instant center for AB. And if our OA is moving that way, which is that's counterclockwise, how AB is moving? Is AB moving counterclockwise or clockwise? Raise your hand if you think it's clockwise. Raise your hand if you think it's counterclockwise.
Wait, if we think AB is moving?
Yeah, AB. What's the direction for AB? Okay, let's look at AB. So AB is this guy here. This is the rigid body AB. Well, if one end of AB is fixed, it would be so easy to look at to see if that is counterclockwise or clockwise. But because the instant center is outside the rigid body, then you have to kind of look at this how one point is moving. That point is also belongs to this rigid body. And if this rigid body is going that way, and this point can only move up, right? Can only go up. If that point can only go up, and this whole thing gonna go up. This whole rigid body AB is gonna go up. If this whole rigid body is go up, this is the point it's rotating about. Now, what's the direction of rotation? This whole thing is go up. This is the point it's rotating about. I cannot tell you how it goes clockwise. Right? If you change the direction of OA, it's always going down, and this point is going down, this whole beam is going down, and now this whole beam is rotating counterclockwise about that point. And right, that's kind of how you can use instant center to look at how rigid bodies rotate. All right, now let me test your knowledge on instant center, and you're gonna apply the 6 steps to another example. Let's still practice here before we do anything. All right. Okay, here we have a linkage system. Linkage H, G, E. Okay, so we have 1, 2, 3, 4, 5 rigid bodies. So here, BD it's the same link, and it just had the GE is pinned at the center of BD. All right, if this is the system we have, how many rigid body we should? Oh no, sorry. Wait. Yes. How many rigid body we have? One, two, three, four, five. We have 5 rigid bodies. And how many instance center we should have? If you have 5 rigid bodies, apparently you probably would have 5 instance centers. Right. There's a possibility some of the instance centers can overlap with each other, but you can find up to 5 instance centers. All right, now it's your job to identify instance centers. Try your best to find instance centers. Label them on the diagram.
How do you know how many,
Rigid body.
yeah,
Just count how many
segments?
beams we have, or how many bars we have.
Oh, okay, so you count this as one.
Yeah, the red highlight one, that's a 1 link. Okay, find instance centers. Okay, I can help you a little bit. I can tell you a couple instance centers. This is the instance center for HG. And this is the instance center for AB. And this is the instance center for FD. And that should be very helpful. Okay, now your job. What the heck is instance center of BD and GE? I already told you 3 instance centers. You find instance center of this guy and this guy. If you don't know what to do, check your notes. You have like 6 steps on your notes, and the first 4 steps teach you how to find instance center. Right above B, it should be the IG. Let's see, B, G. Why? Okay, let's see if that's the right spot. Yeah, if you look at the steps, let's look at B, Let's look at GE first. So being GE, you want to find out 2 points on the rigid body that you know the direction of velocity vector. So it's a different color here. What's the direction of velocity vector for point G? Use your finger, tell me the direction. Pointing to the direction of motion of point G. I'll see your fingers, guys. Okay. Right, it should either go up or go down. Thing that's consistent. If this guy is moving that way, and this should go up, right? Okay, and we know 1 point on this rigid body is going up. How about that point, the direction of velocity of point E? Well, that's kind of hard to tell. I don't know. And it's hard to tell where's the direction of point E. Okay, now it's okay. Let's leave this part. Let's look at the rigid body BD. I think it would be easier to find out the instant center for rigid body BD. Let's first look at what's the direction of point B. Use your finger, tell me what's the direction of point B. Okay, point B will either move that way or that way, right? So point B is either going that way or that way. How about point D? Your fingers. Okay, that's kind of an angle, either go that way or go that way. I think that's a smart way to show it. Pretty. Okay, right, now it's pretty clear. Let me redraw this. Okay, now we know the direction of 2 points on this rigid body BD. Now we can draw perpendicular lines to those directions. Let me use a different color, red. The first line is here. This is perpendicular. And the second line here, perpendicular to that direction. Boom, we have the intersection. That tells us the instant center of BD. All right, raise your hand if you figured out that point, BD. Okay, good. Okay, now we know the instant center for BD. We still want to find out instant center for GE. Let's look at that point E. Is point E on rigid body BD? Yes, point E is on the rigid body BD. Okay, can we do this reverse? To use the instant center to find out what's the direction of point E. Now we know the instant center of this whole rigid body. We know this is a point on the rigid body. Can we use the instant center to find out the direction of point E? Where's the motion of point E? Yes, we can. Think about what we did here. The connection line between the instant center to this point, that line is it's perpendicular to the motion of point B, right? So that tells you if you connect any points between the instant center to the point on this rigid body, that line should be perpendicular to the motion of that point. So if we can draw a line from point E to the instant center and draw a perpendicular line to that, that would tell us the direction of point E. Let's try that. Okay, let's first connect point E and the IC. Okay, and then I use the blue color to draw a perpendicular line to the dashed line there. This blue line tells me the direction of velocity vector of point E. Can you see that? We use this
Reverse.
so that it helps, the instant center helps us to decide the direction of velocity vector of any point on the rigid body. So now we can look at rigid body GE. At GE, we know 2 points, G and E. We know the direction of both points, and we can do the same drill. Can start to draw a perpendicular line to that. Oh, wow. It's here. The intersection. I see. This is GE. Yeah, the instant center for GE is a little bit tricky. I want you to all look at the whiteboard. Look up here to see, look at the location for ICGE and compare that with your answer. And raise your hand if you get that right. That's pretty good if you can get that on your own. Like some of the rigid body has tricky instant centers. You cannot have to find it by finding other instant center first. But this is the point of instant center for rigid body GE. So once you have instant center, if you want to note all the directions, if you look at point E, we didn't know if point E is pointing that way or that way, but now you have instant center, you can decide whether direction of point E. We know the instant center, we know this beam is rotating about that instant center. G has to go up. If G has to go up, there's only one way that we can move point E. The point E can only go that direction, right? So that helps you to decide the direction of velocity vector. Okay, now it's a practice time. One more practice for you. Now we have another system. We have one link here. It's A and B. And A and B is connected with another link. Let's call this D, E. Okay, if we know link AB is moving, rotating counterclockwise. All right, your practice, you're gonna use the rest of 6 minutes to find out the location for the instant center for AB, IC for BD, and IC for ED. It's your practice. And actually, it's the same diagram from your problems homework to BC. Okay, you can talk to each other. Talk to your neighbors to see if you guys have the same location for internet. The instance center for A, B, and E, D is pretty easy since they're fixed at one end. So that would be their instance center. But for the rigid body B, D, you have to identify the location, direction of vector, velocity vector at 2 points on the rigid body, find their direction of motion. For point B, has to go up. For point D, can either go right or go left. From there, you can start to draw the perpendicular line. First to B, perpendicular line. Another one is for D. Yeah, where's the intersection? In order to find intersection, we have to extend this line, right? We gotta, okay, this is an intersection between these two right lines. So right here at point D, it's actually the instance center for BD. That's on your problems homework. 2A, 2BC. All right, your concept homework 2BC is due this Wednesday. And your problems homework 2BC is due this coming Monday. Next Monday, you have 7 days to do that. Okay. And your pre-homework 3A is also due Monday. All right, that's all we have today.